Hey everybody, it's Eugene Liscio, and welcome to Click 3D. This is the program where we talk about how we can use simple technologies like your mobile phone to create realistic photogrammetry models. And I'll be discussing tips, tricks, and different kinds of things that you can do. Today, we're going to be talking about video and whether or not you can actually use video to create 3D models. So the question is, can I use video to create 3D models? And yes, in fact, you can. So there's a lot you can do with video, but you have to understand what the differences are between, a regular camera and, a video camera, the way that they're used, and both even in terms of the hardware and sort of physically how they operate. So let's start, and let's start with the very first thing that we need to address, and that is what's the difference between a digital still and video camera. There's fundamentally some major differences there that we need to address. So let's go with that first. So let's see. Well, I think it's kind of obvious. If you have a regular camera, like just a point and shoot camera, there's the first point, which is it's one photo at a time. You're really just sitting there and, you just click, you take one photo, and then you take your next photo. Now, of course, you can take a lot of photos rapidly or whatever, but it's really intended as taking one photo at a time. And there's some advantages in doing that. If you have time and you're going to point and shoot on a particular object, you can control the camera. So you have a lot more control over the shutter speed, the exposure, a whole bunch of different things. You can hold the camera a lot more stable because you're going to be on a tripod. Now, with a video camera, the operation or the intention is different. So you're going to be, let's say if we took this and we put it into video mode, well, the idea is that I'm going to be moving. So I'm actually going to walk around and I'm going to be pointing the lens at different places. And, it allows me to get a lot of images captured, per second, or there's a particular frame rate. So on most cameras, it's going to be, about 30 frames a second or 24 frames a second. And nowadays with modern phones, you can get up higher to 120. On GoPros, you have like 240 frames a second. So there's some advantages to the frame rates and different things that you can do between the two. So we talked about the fact that a still camera has a lot of control. And so that could be one thing which is detrimental when you're using video. So if I'm just kind of like walking around an object and all of a sudden lighting changes, or there's a window open and whatever, there's a lot of strong sunlight coming through, I can't really compensate for that. So I have to sort of live with the way that the video reacts to the particular environment in terms of the lighting and that sort of thing. The other thing that happens is if I'm walking with a video camera and I'm walking around a subject or something like that, I have a tendency to get blurring in the images. And the faster I move, the more blurring I'm going to get. So if I wave this thing around really quick and it's not stable, or it's not gimbaled, or something like that, it's not stabilized, then I may have some problems with the individual frames. It may look okay when you're looking at the video, but when you stop it and look at individual frames, it tends to become a problem. And that's where the digital camera has an advantage. When you're on a tripod, you can avoid and do things which avoid a lot of blurring. Now, there's some things that you can do which will compensate for that. But the other thing that you should understand with video is that there are different types of shutters on cameras, regular cameras, and also video. And I'm going to bring up a page here that I found online, and I think it's pretty good. But here you'll see, it talks about the difference between a rolling shutter and a global shutter. And I think it's pretty simple. A lot of people have seen this effect. So for example, where this helicopter is on the bottom, when you have a rolling shutter, it's basically moving line by line down this, the rows of, your sensor kind of thing. And as something is moving horizontally or up and down, you may catch it in one of the lines, but you may miss it after, or it just becomes highly distorted. So on the top here, when you have like a global shutter, you'll see that the rotors on this helicopter look all straight and look fairly normal. But here on the bottom one with a rolling shutter, you get this curved effect. And so that's something that is fairly common. So the global shutter, you can think of it that it's basically just open and then close. So it exposes, the idea is that exposes all of the sensor at once, and then it kind of shuts down again. So almost like, you're blinking with your eye, you see the whole picture at once, and then you shut it down. So I'm going to play this little video here, but you'll notice the difference at the bottom here where you get these curved blades. So it looks kind of weird. And if you have a GoPro or a phone or something like that, a lot of them, you'll see this particular effect all the time. And it looks something like this in this little graphic here. If you, on the left, okay, you'd have like a global shutter. You see the little wings on this windmill kind of thing looking all nice. But over here, where you have the rolling shutter, they get heavily distorted. So what does that mean for you? Well, actually, here's another example. This looks pretty good too. So you'll see the rolling shutter moves down row by row by row. Total shutter or global, it's just going to expose the whole sensor at once. Okay, so that's the basic premise there. Now, what is good and bad about that? Well, the good thing is it's great for recording images quickly. So on a GoPro or some drones and things like that that have a rolling shutter, you get pretty good footage. And for most things, if you're just doing just a regular video that you want to show somebody, it looks pretty good, right? It's not too bad. But the downside is that if you're going to be recording something for 3D reconstruction, if it becomes distorted in the image, there's no way that it's going to reconstruct properly. Okay, so the type of equipment that you choose, if it's a global shutter versus a rolling shutter, keep that in mind. You can figure it out. Just look at the specs on your phone or your camera, whatever it might be, and then you can find out whether or not it's going to be useful to you or not when you're doing a reconstruction. Now, some things you can do to help with that will be to slow down the movement. So if the object isn't moving and it's just you that's moving, if you move slower, you're going to have much less distortion. So in the case of a drone, when you're flying the drone, you're not going to be flying at high speed, recording video. What you want to do is just really tone it down, go very, very, very slow. On some drones, like I know on the DJI systems, there's different modes. So you're not going to be in sport mode, flying around like crazy. Turn it down to the cinematic mode or a very slow, highly controlled rate of movement, and having that nice slow and gradual movement will be very, very helpful to you. Now, the other thing you can do, especially with video, is that you can increase the frame rate. And this is something that is really, really useful. So I'm going to show you a video of something here. And this is a skull. And this is the first time that I attempted this with an iPhone. So I'm just going to play this video, if it'll go here. And okay, it looks a little choppy here on the recording, but basically I'm moving around and I'm in close. Now, I'm not moving around the object, I'm moving the object and keeping the camera kind of in the same area. So this is a technique that you could use when you're trying to create a 3D model of different evidence or something small. And you're kind of tricking out the software in thinking that the camera is actually moving. And when you do this type of a setup here, you're going to want to get in really close. And I'll just play that again. And you don't want to have a lot of the background, okay? So you can get into trouble if you keep a lot of the background there. It'll have a very difficult time in reconstructing. Now, the trick here was that when I recorded this, I actually chose 120 frames a second. So I was using the higher frame rate on the phone, and as a result, that also reduced the amount of blurring. So that was very, very helpful. And what I'll do is I'll just move in here and I'll show you the 3D model. Now, let me bring that up here. There we go. And I'll just click on this and see if we can bring up Cloud Compare software. It's something that I like to use. And let's see if it opens up. Well, it's in my other monitor here, but let me drag it over and hopefully you'll be able to see it. So based on the video, this is the skull that was created. And it wasn't all that hard to do. Of course, you don't just, you can drop in the video in some programs and it'll extract the frames for you. But in this case, I actually extracted the frames myself and then created the model. So it's not bad. There's some pretty good features here. But one thing that you'll notice between a video and a camera, a regular camera, is that you typically get a higher quality model from digital stills. And that's because the resolution is going to be much higher on a digital camera, a regular digital still camera. Now, although the model looks pretty good, I could have done better with a digital still, but it was really fast. It avoided me from taking a lot of photos, and in a 20 or 30-second video, you can capture a lot of overlapping images. And that's the benefit of video. Because you're recording at a higher frame rate, this one might have been at about 120 frames per second or so. I have a lot of overlapping photos, or images. So there's no chance that I'll capture one side and then just the other side with nothing in between. There's always going to be this gradual transition to one area to the other. So having lots of overlap is going to be super, super helpful. And yeah, that's kind of what it looks like there. Now, let me show you another example. I think this might be useful too. So this is another Bones project that I did here, but let me zoom in on this. And now this is a slightly different approach, because what I'm doing is I'm moving around the particular object, and for whatever reason, that's not playing all that well. So I apologize about that. It's actually skipping here. So let me see if I can bring the actual video up somewhere. So just give me a second here. I want to see if I can fix that, because it'll look a lot clearer when I bring the actual image. So how about I try, hang in there with me. That was a great project that I did. And boy, it doesn't look like it's coming up. Let me see if I can play it here. And if you can see it here. Is that any better? Yeah, it does look like it's a little bit better. So when it's not in the other section, it's a little better. So that's kind of what I'm getting. So what you want to do is take the phone, you want to move in around the grave, cover all the different areas, get a lot of overlap. And by doing so, you will have enough images to create a nice 3D model. So let's go back into and see if we can get into the model. So I'm going to open this up again in Cloud Compare. And there we go. So this is the resultant model. And I would say this is not a bad model at all. We have pretty good details here, because as I'm moving the camera around at a higher frame rate, I get less blurring. So the closer you are to an object, so if for example, if you're moving your phone at the same speed and you're 50 meters away from an object, and then you're only 5 meters away from an object, if you're moving at the same speed, the one that's closer at 5 meters is going to experience a lot more blurring in the images. And so that the way that we offset that is going to be by obviously just increasing the frame rate. Okay, so that's super, super helpful. Okay, so that's the model there. Again, this is not where the object is moving. This is where you're moving around. And again, just make sure you take nice, smooth motion. You don't want to go too fast or make really, really jerky motion. Otherwise, you'll get a lot of blurring in between the particular images. All right, let me close that one. And I'm going to go to another example. And let me see if I can go here. All right. So this one is an example where I've taken a GoPro, and instead of taking images, I've taken video, but I've just put it on a pole. So I know drones are really popular with a lot of people, but in some areas, you might be good enough to just use a pole. So I've experimented with this several times with video and both with still images. One method you could use if you just wanted to use a digital still would be to use the time lapse on the GoPro and basically set it for every second or every couple of seconds, and it'll just fire a higher resolution shot. But I can also use video. So I'll let you look at what I'm doing here, and maybe I'll give it a little description. I'm hoping this is going to play here. Okay, so it's not great, but you'll see that there's a little bit of wobbliness there, and part of that comes from the rolling shutter. And then what I've done is I've taken a path from side to side and slowly walking forward. And you'll see I go over to the next side and sort of in a zigzag motion across the roadway. And I found that this works pretty well. Now I'm not moving very fast because in this one, I think I was only using, the regular frame rate, about 30 frames per second or so. And it can sometimes be a little tricky with the camera on top of on top of a pole kind of thing. And the GoPro is kind of small, so it can move around pretty easy. If you have something heavier, I guess it has a little bit more inertia. But you see here that I'm just walking down the roadway, not doing anything too crazy, just making sure that I keep this zigzag motion. And the zigzag motion allows for a lot of overlap side to side. Another approach that you could use here would be to walk straight up and down the roadway 3 times, like starting on the left side of the road, then starting on the right side of the road, and then then once in the middle, and you'd have 3 sets of overlapping images. Now, if you walk just straight down the road and you just try to use one set of images, it's not the best. Okay, what you want to do is try and have like you had 3 cameras going down the roadway at once. And you'll see here, I drew a straight line back. I just walked straight back, and then I've got a whole bunch of images here. Now, of course, I only walked with the camera facing one way down the road, and then you see I bring it down here. All right, there we go. I'm just going to play this again. All right, so I'm going to stop here. And one thing you could have done that I was talking about in the previous section is, as you're walking down the road, you can also turn around and come back the other way. So you get some really good overlap, and then you get basically perspectives from both sides of the roadway. Now, that's only useful really if, for example, the car that was off to the side, I moved one way, so you'll see one side of it will work well when it gets reconstructed, but the back side where I didn't have anything is just going to be a mess. It's just going to try and fill in the holes or whatever, and it's not going to look that great. So making sure you get good coverage with the video camera isn't all that difficult. Just move around, and it's super, super quick. So the next thing you have to think about is how you're going to extract the images. So there's different software you can use. I use Input Ace. I've got Premiere Pro. There are other things like VLC, which is a free program that you can use. And basically just extract these images. Now, when you are extracting the frames, you don't need to do a ton of them. So if you have 60 frames a second, 30 frames a second, or higher frame rates like 240 frames a second, you really only need 1 or 2 images per second. At least in this example, I wasn't moving all that fast, so I would have only been moving a couple of meters or so, maybe 10 feet or something for every second. So that's good. It would allow me to have enough overlap for the reconstruction. Now, the other thing too is that a lot of software today that I use, anyway, they've incorporated the video as a type of import. So you can just drag and drop video directly into the software, and what it'll do is it'll automatically extract frames for you, or you can tell it, look, I want 1 frame every second or 5 frames every second, whatever it is that you want, or however much that you think you need. So that's really a really great benefit. So sometimes if you want to extract it yourself, you can in other software, but a lot of the software like Photo Modeler, 3ds Zephyr, I believe Agisoft might have that as well, but you have some choices here. So bringing in video is not a problem. So let's have a look at what this model might look like. So I'm going to go over here. This is a 3D model of what I was able to produce with just walking down the roadway with a GoPro. So nothing special. You can see all the camera positions that were calculated here, and you can see my path as well. I've got this zigzag motion that I was going down the roadway. Okay, I went back here, and then starting somewhere, I don't know, is that even the center of the road? Oh, kind of the center. I just walked backwards and made sure that I had the camera pointing in the same direction to about the point where I started. So it doesn't look too bad. When I was talking about the vehicle, you'll see that this side of the vehicle, now cars are difficult in general. And if you had watched the the previous episode, I talked about cars being a little bit difficult. So here you can see I've got a vehicle. I only had the camera pointed one way. So guess what's going to happen on this side? Oh, you get a bunch of garbage. Okay, it doesn't look great at all. Now, had I turned the camera 180 degrees around and walked down the road and done a similar thing, this would have been a lot more beneficial. So video is absolutely possible. The quality, if you go down on the roadway, you'll see that the texture is okay, but it's not great. Okay, it's not the best. And again, that's because there's a little bit of blurring when you get down to those fine resolution. You're not going to get a nice crisp image. So if I wanted higher detail on the roadway, two things you could do with the video camera is get closer, move slower around a particular object or something that's on the ground, or switch to digital still. And if you have digital stills at high resolution, those are going to work out the best for you. Okay, so that's it for pretty much video. It's absolutely possible to use. It's a great tool if you need to move quick, and that's really the benefit. But just remember that the quality of the reconstruction is not going to be as good as if you were using a digital still camera, you know, especially today with some really high megapixel cameras. You're going to get a lot of very crisp resolution. Also, video cameras, you know, again, resolution, you know, there are 4K video cameras nowadays, not too bad, but a lot of them don't record at, you know, 120 frames or 240 frames a second. So if you move up to those kinds of frame rates, then you can expect to get down to about, you know, 1920 by 1080, or in some cases, if you have a 2.7K video, you'll probably get down to about 60 frames per second. So that's it for today. Hopefully you learned something with respect to video, and we'll see you next time on Click 3D. Thanks a lot. Bye-bye.